The idea in this section is to verify trigonometric identities. And this is, instead of simplifying expressions, in some ways it's clear because you have two things on either side of the equal sign and you want to make them look the same. You can work with one side of the equation at a time, sometimes with the more complicated side first, looking for opportunities to factor, add fractions, square binomials, make a single monomial denominator, try to use your other identities. Think about comparing up sines and cosines with the sine squared, cosine squared, other Pythagorean identities. If none of that works, convert things to sines and cosines. And the main thing is always try something. You keep having to keep at it, and eventually you'll get something. A lot of times when I go into these problems, I don't know what I'm going to do first. I just try something and hope it works, and if it doesn't, I try something else. So the first thing we want to do is to verify this identity. So what I've done is I took the left side and I factored out a sine to the 1/2 x and a cosine. So when I factor out sine to the 1/2 x cosine, this whole piece becomes 1. This whole piece becomes sine squared because the cosine gets factored out. Sine of the 5/2 minus a half is just 2. And then on the right, I haven't changed it yet. Now what I can do is just a couple things. I divided off sine of the 1/2 on both sides, and this piece went away, and this piece went away, because rad sine x is the same as sine of the 1/2. And then lastly, 1 minus sine squared is the same as cosine squared, or another way of looking at it is I divide cosine off both sides, so this cosine goes away, this cosine cubed becomes cosine squared, and 1 minus sine squared is cosine squared. That's a Pythagorean identity, so that's good enough. Okay, in this one, there's not too much to do here, honestly. On the left side, 1 plus sine y is just 1 plus sine y. Now here you've got to remember that sine is an odd function, so sine of negative y is the same as negative sine y. So this piece becomes this. Now I can do binomial multiplication. It's the difference of two squares, so I get 1 minus sine squared, which is cosine squared, so that's okay. We verified that identity. This looks like kind of a beast at first, but what I tried was cross-multiplying. So I've got these guys multiplied equals these multiplied. Now you just distribute stuff and realize that when you distribute, say tan x times cotan x, cotan y, tan x times cotan x, that cancels. That's equal to 1. That's just cotan. This would be minus tan. Tan y and cotan y cancel, so this is just cotan x, and then minus tan y. So when you do all that, a lot of things cancel. Now the same sort of situation over here, you just distribute 1 times cotan, 1 times cotan y. Over here, the tan x cancels with cotan x, you get minus tan y. The last one, the tan y, cotan y cancel, you get minus tan x. And you'll see that every one of these terms appears over here. And so the identity is already done just in those quick steps. Let's see, for this one, I just played around with the left side. I distributed the cosecant to get cosecant squared minus 1. I thought that would be good because cosecant and sine cancel out to give you 1. And then over here, I actually divided. So sine divided by sine is 1, and cosine divided by sine is cotangent. And so, and then I've got a plus a cotangent over here. So the cotangents cancel, the 1's cancel, and you just got cosecant squared is cosecant squared. So I distributed over here, divided these, and then cancels out. Next, let's see, for this one, dividing by secant is like multiplying by cosine. So instead of dividing by secant, I put out front as a cosine, and then I rewrote cotan as cosine over sine. Now, if I distribute cosine, well actually, you know what, instead I did was, I see there's a cosine here, cosine here, cosine here, so I just divided cosine from everything. Why distribute things in when you can just get rid of them from every term? Now when I get to here, well, 1 plus cosecant, and 1 over sine is the same as cosecant. The cosecants cancel, and you're good. Now for this problem, this is the difference of two squares, and we're going to use this in a minute. It's actually a difference of 2 fourths, but you can write it as a difference of two squares like this. And then the left side, cosecant squared minus cotangent squared, due to this Pythagorean identity, that's just 1. And then meanwhile, I changed cotan squared into cosecant squared minus 1. And then forget about this 1, I got cosecant squared plus cosecant squared minus 1, and so these are the same thing. So I factored, this whole thing became a 1, I changed this into cosecant squared minus 1. And finally for this one, nothing changes on the left. The only thing we do is we take the negative and put it inside as an exponent. Cosine theta to the negative 1 is 1 over cosine, which is secant, and so there you go, ln secant equals ln secant.